good morning everyone. Hannah and King, good morning. So before we start our lesson today, let's have a quick review first of what we talked about yesterday. Okay? Now I know you guys are familiar with this one. I'm gonna start it and try to guess. If you know the answer, just raise your hand and see if you can give me the name or the word and try to give a brief explanation, okay? Any guesses? 2 words. A wave. What kind of wave? We have 2 types of waves. We have the mechanical, and this one is another one. Light is one of them. Any guess? That should be a giveaway already. Electromagnetic wave. So Hannah, can you tell me something about electromagnetic wave? What is electromagnetic wave? Do you have any idea? Light, X-ray, gamma rays, these are examples of electromagnetic wave. Any idea what electromagnetic waves are? So when we say electromagnetic waves, these are a type of wave that does not require a medium, be it solid, be it liquid, be it gas. Next word, that should be easy. A U. M. A medium. Good job, Hannah. Again, what is a medium, Hannah? Not the small, medium, large, okay? What is a medium?
Substance that things
Please speak a bit louder.
Substance that things can travel to.
Substance that things can travel to. So we can say solid, liquid, or gas. For sound waves, you guys can hear me because of what medium? Air, right? Good job. Next word. What is this? You got a T, another T, starts with an R, and an O-N. It's the first lesson we discussed. Reflection, good job. King, reflection of light. Give me an example of reflection of light. Mirrors. When you look at your face, you see a handsome or a beautiful figure on the mirror. Sometimes when you just woke up, no, probably. So reflection of light. This is more obvious when you look at yourself in the mirror. Last word. What is this word? Start with a T. R. Another T. What? Did you say transportation stuff? It ends with a T. Transparent. Good job. What is transparent? When do we consider an object to be transparent? You can see through it, or light can pass through it, right? Example, that glass door. So you can see through it. The light can pass through that object, right? So these are some words that we've discussed yesterday or the days before. Now, let's start with our lesson for today. We have refraction of light. Do you have any idea what refraction of light is? So we talked about reflection. What about refraction? It also starts with an R and an E. But what is refraction? Look at the diagram, the picture. What can you see? Everyone's familiar with this one. What do you call this? A triangular prism. And then you have this one. And then, what do you think happened? It formed rainbow. How many colors do you have in the rainbow? You have 7. Roy GPF. Now, we're going to be talking about refraction of light as we go along this lesson. Now, these are the objectives that we need to achieve before the end of the lesson. First, we're going to explain the concept of light refraction and why it occurs. Second, we conduct experiments, simple experiments, to observe how light bends through different materials. Third one, we'll try to identify and relate real-life applications of refraction to everyday experiences. Because sometimes kids try to learn something in school, but they forget to know the importance or how relevant it is to their lives, right? So we're going to figure that out today. Now, before I discuss and explain to you what refraction is, I have this arrow. What do you think I'm going to do with this arrow? Have you ever seen this before? Not like magic or something. I kind of don't believe in magic. I think everything can be explained with science. Do you believe me? So what's going to happen is I'm going to place this arrow behind this water with glass. Oh, glass with water. So what do you think would happen? You want to know what happened? What can you see? It's opposite. So this arrow is going to which direction? To the left. Is that your left? But when you try to put it behind this glass of water, what happens? So it's moving to the right, right? It's pointing to the right, to the other direction. Can you see it, right? But if I get it closer, you wouldn't be able to do it. So you have to get it a little farther from the glass, and then you can see the refraction of light. Now, this phenomena will explain to you the basic rule of light refraction. Now, let's try to identify and define what refraction is. What is refraction? What do you think? That was your assignment yesterday. Can someone tell me what refraction is? Hannah?
When the path of a light is changed as it goes through another medium.
Good job. So when the path of the light changes as it goes through a different medium, what about you, King? What do you think refraction is? You don't know? Okay. Now let's define what refraction is. Refraction is, King, can you please read?
Refraction is a bending of a wave when it's passed from one medium to another.
Mm-hmm.
The bending is caused due to a difference in density between two substances.
Okay, good job. Thank you, King. Now, if you're going to look at this, as mentioned by Hannah earlier, refraction is the bending. Refraction of light as it passes through one medium to another. Be it from air to liquid, from liquid to gas, from gas to solid. So, light is different from sound waves because sound waves are mechanical waves. They need a medium, like solid, liquid, gas. But for light, they do not need a medium. Okay? It's not like it travels fastest in solid and then liquid and gas. For them, light actually travels fastest in air and then slows down as it travels to liquid or even in solid. Okay? That's why there's bending, because there's a change of medium, as Hannah mentioned. We also have the word density. You know what density is?
The amount of particles in space.
Good job. So the amount of mass or particle in a given volume, right? That's density. Or in layman's, you could say how heavy or how light the object is, right? So that's density. Now, there are different terms that you need to remember in order for us to understand what refraction of light is. First one, incident ray. What is incident? What is the synonym, or what is incident? Don't know? Okay. Well, in science, in light refraction, incident ray is the ray traveling towards the boundary. So that's the first ray, before it hits another medium or another material. What about refracted ray? What do you think? Refracted ray. King, any idea? No? So when we say refracted ray, this is the ray traveling away from the boundary. So as it hits the surface and travels to another type of material, then that is the refracted ray. If we have the refracted and the incident ray, we also have the normal ray, from the Latin at an angle, at a right angle. So this is perpendicular to the boundary or the surface before it hits another medium or another material. So straight line perpendicular to the boundary at the point of incident. And then we have angle of incidence. If you have incident ray, you should have angle of incidence. In your math, you've learned like angles, right? So in physics, you all know that it's also like partly math, right? But with a mix, with a touch of science. So angle of incidence, this is the angle between the incident ray and the normal. Later on, I'll show you a video so that I could also show you what these are. And the last one is the angle of refraction. This is the angle between the refracted ray and the normal ray. I do have a material here, I'll show it to you later, and also this glass and the laser. We'll play with that later. Now, before I show you that, let me show you a video first. This is best shown when the light is off. You see that? Let me pause the video. So which one do you think is the incident ray? Which one is the refracted ray? So is this the incident ray or is this the incident ray? King, what do you think? Which one is the incident ray? The first or the second one?
First one.
The first one. So the first one is your incident ray. What do you call this one? What do you call the second one? The refracted ray. Now, earlier I mentioned about the normal. So where should the normal fall? Perpendicular. So you have to do this in the incident point. So you have this. You're just going to have to draw a line here that's perpendicular to the surface of the water, right? If you have a straight line, when it's actually straight, do you think it's still bent? Let me move it to the, yeah, down. So it's straight. Do you think it's still bending? Is it still bending? Do you see a refracted ray in here? No, King, right? Why? Because it follows a straight line. But even if it's not refracting or bending, that doesn't mean that there's no change of speed. Since this is air, this is water, there's also a speed of change in the speed of light. So this kind of slows down as it enters the water, although the bending is not happening. As you move, you see that it's also changing. Okay.
Have you ever wondered how scientists and...
Now let's go back to our PPT. Did the video explain the incident and the refracted ray? Did you understand it way better now? Yeah, good. So let's try it with this one. So I gave you this. You could try it right now. I think this would work best if the light is off. From the side, kid. From the side for me. Maybe from me. No, that's not a laser. No, that's not a laser. The other one. There's another button here. This one. Okay, good job, Kate. As you can see, the light is bending as it travels through the glass side. It actually is bending, right?
Yeah.
Why do you think it's bending, King? Why is it bending, King? Because it enters a different material. Now, this one is denser. The glass is denser compared to the air. Definitely, the speed of light would slow down, right? Now, I also have, let's try this here on the board. I actually drew it earlier. Now, if we're going to look at this, let me use a different one. Hannah, can you draw the normal, you have, if you're trying to do the diagram or draw the incident ray and the refracted ray and the angles, starting from the normal first. Go. And then later on, he will do the next one. Just do a broken line. So you're doing the normal, right? Okay, good job. I think we need to add more here. Okay, thank you. Now, we do have the normal. This one is the normal, forming perpendicular to the surface, forming right angle. Can you help us with the incident ray? Okay, so we have the incident ray. So this is incident ray. Now, will it follow a straight line? Definitely not. Why? Because we're changing the medium, right? The material is changing. So this would slow down. Okay, so that's going to slow down. So this would slow down, and we would call this as the refracted ray. Now there's one thing also. As it travels out from this material, it would go back to the same position, to the same direction. The direction has to be parallel with your incident ray. So let's say it's straight. So if you measure, so this is your emergent ray. Your emergent ray and your incident ray should fall parallel to each other. Okay? Because you're changing a medium and then you go back again to the same type of medium here, so that should go back to the same direction, which should be parallel. Now, we can also get the angle of incidence and the angle of refraction. How do we do that? How do we get it? From the normal. If we try to use this massive protractor, so we have this, and this is going to be your, what is this? Your angle of incidence, right? So what is the measurement? So that is going to be, I'd say, what is this? Like about 100?
How did you measure 100?
Oh, what is the measurement? Tell me. 27? From here all the way here. Go. 50? Okay. 50. So let's say 50 degrees is your incident ray, angle of incidence. What about the angle of refraction? 20? Okay, we can say this one is 20. Now, which one is greater? Which one is greater? The angle of incidence or the angle of refraction? The angle of incidence. Good job. Is this clear right now? Now, I'll give you a very short activity. Oh, by the way, I got this from our science lab. This is actually good for us to show and play around with the angle. Look at that. So you can start, let's say you do it like this, and then you can see the bending of light, right? And you can already see the angle. If you want to change it, like that, you would see it, right? Now I'll let you play around with this later on. Now let's have a short activity. Using a pencil and a beaker of water, you guys will be working on a simple experiment to show refraction. Now I have here the materials, and then all you have to do, Place a pencil in a beaker of water at an angle. Observe how it appears bent at the water surface. And then once you're done, explain your diagram. Try to draw the diagram of the incident ray, the refraction ray, the angle of incidence, angle of refraction, the normal. Try to use the A3 paper I gave you. And then after 10 minutes, you guys will need to present it. Okay? Your time starts now. Guys, finished? Okay. Hannah and King, can you present your work for the class? Maybe you could show it also, King.
Okay,
So first of all, we draw a normal line in the middle of the paper,
Mm-hmm.
and then we draw the the boundary, which is the surfaces of the water,
Mm-hmm.
and then
and then, yeah, and here we have the rate, the incident rate and the refraction of refracted ray.
which is this one and this one.
It looks kind of bent, right?
Yes.
But it's actually not. Since it is passing through a different type of material, it would definitely look bent. Okay?
This is the angle of incident and this is the angle of refraction.
Mm-hmm.
And the normal line is drawn perpendicular to the boundary line.
Did you measure the angle of incidence and refraction?
No, didn't.
No. If we do an estimate, what would be the angle? Because we don't have a lot of time.
15 and 30.
Okay, we could say, let's say it's the same. That's 50 degrees for the angle of incidence, and what's the other one? 20 for the angle of refraction. Anything else you'd like to add? All right, good job. Thank you. All right, looks like you guys have better understanding now what refraction of light is. Now, as mentioned earlier, light can travel to different medium, right? So if from air into glass, as you can see here, this is the incident ray, this is the incident point, meeting the surface, and then the normal one, and then it bends. Same goes from the glass into the air. We'll do a little bit of math tomorrow. Okay, there's a big computation behind that, but we're not going to get to that. The focus right now is for you to learn the concept of refraction of light. Okay? Now, there are also, of course, these things you should know the importance of how is it being used in our daily lives. Now, there are some real-life applications of refraction. Example is consequences in eyeglasses. Who wears consequences here? You do, but you're wearing eyeglasses. I also wear consequences, but I'm nearsighted, so I don't need that. Eyeglasses. How is consequences or eyeglasses using refraction of light? Hannah?
They bend the light.
They bend the light, right? So they bend the light in order for you to what?
For the light to focus on your eye.
Focus. So the light, because the light is coming from that material, so they will try to do some tricks in order for you to be able to see it perfectly. What about for a camera? Who likes photography here? She does, but you answer. What? How is camera using refraction of light here?
Maybe for focus eye on the sensor.
A sensor, okay. Hannah, what else? What do you think? How is the refraction of light being used for camera?
We already mentioned it.
Okay. We'll get to that more because we have an activity next week for you to give me some details of how we use refraction of light in our daily lives. Third one, microscope. Hannah, how is microscope using refraction of light?
They use the lenses to bend the light,
Mm-hmm.
magnify it.
And magnify it using the eyepiece, right? Good job. So this is just some of the uses of refraction of light. Now, Before we end, as your exit ticket, I bet other classes do have their exit tickets. I do have 4 questions here. All you need to do is just pick a number and try to answer. We will be starting with Hina. 2. What happens to light when it passes from air into water? It refracts or it bends, right? Because there's a change of medium. Good job, Hannah. Next one, King. Number 1. Why do objects in water, like a straw in a glass, appear bent or broken? Actually, almost the same question, but it's just
change.
because refraction of light, right? Because it's passing through a different medium from light. Why do objects, like what we did earlier, right? Instead of a pencil, we have here a straw. So it's also the same thing. Next one, Hina. 3. How does refraction affect the way we see objects underwater? Makes it bent. So the light coming up from that object, it's like an optical illusion, right? It's bending because there's a change from water to air and it looks bent, right? Next one. King, do you need to choose a number? Number 4. How does the angle of incidence compare to the angle of refraction when light moves into a denser medium?
The angle of incidence is bigger than the angle of
Mm-hmm.
refraction.
As you can see here, and also from your activity, angle of incidence is definitely bigger compared to the angle of refraction. So all these questions actually come to, it's just a single answer, right? I just want to test how you guys understand and comprehend the question and how you apply the concept we learned today. Good job. You can give yourselves a round of applause, guys. Now for your homework tomorrow, we will be working on the mathematical equations behind light refraction. If you have any questions, please let me know. Thank you.